Hello everyone, Bill Garvin here. In this webinar for Gnold, what we're going to be covering is machine maintenance. This one's referred to as Machine Maintenance 2.0. We're going to go into a little more detail other than just, where to clean and where to oil your machine. We're going to go through several parts of this webinar and explain the aspects of your equipment, what the pieces are, what they actually do. We'll be talking about troubleshooting issues, if you're seeing something happen on your machine, things that you can check yourself, before you panic too much and just think you're completely out of the embroidery business or need a technician. Always start with the simplest things first. So what we're going to do is, first thing we're going to talk about is going to be the tension, the bobbin case, and the rotary hook, and the timing of that rotary hook on your commercial embroidery machine. Now keep in mind that all machines are slightly different. They operate a little differently, but in the end of the day, how they create a stitch, they're almost all identical. So we're going to be covering a lot of information, but keep in mind that machine specific, you may need to reach out for additional information on your particular piece of equipment, but hopefully what we cover today will help you immensely in troubleshooting issues and stuff with your equipment. So to get started with, we're going to talk about the tensions on your machine. Probably the first and most important thing that you want to do is to have a good quality brand of thread, okay? Industry standard nowadays is a standard 40 weight polyester thread. Okay, so if you're using like the Gnold 40 weight thread and you're in love with your thread, there's no reason to change. Thread is probably the absolute cheapest thing that we use in every day of production. Okay, it is literally pennies per shirt when you think about a 5,000 meter comb that costs anywhere from $8 to $10 a comb of how many pieces can actually get done. Now when you look at the tension knobs on your equipment, so keep in mind that the manufacturers, the people that build your machines, whether you got a 12 needle machine, a 6 needle, a 15 needle, and even some machines are made up to 24 needles in a needle case now. The first tension knob is not any different than the last tension knob or any of the ones in between. Therefore, if you've got consistently the same weight or type of thread in your machine, your tension knobs are actually going to always look the same. As a technician and doing service on equipment, we run into this pretty often because the number one thing that most operators and owners like to do when they see an issue, they break a thread, they've changed the needle, they're seeing a little white thread, they're seeing a little looping in the design. Well, what they're wanting to do is turn the tension knobs. It's like the number one go-to thing that everybody wants to do on their equipment. The truth is those knobs are hardly ever meant to be touched, moved, or adjusted. The reason there is actually tension knobs on your machine is simply for specialty threads. For example, if you're using a metallic thread during the holidays, it's available in a lot of colors and at different weights. It's a very coarse, abrasive thread, and you normally need to loosen the tensions on your equipment for it to run better and smoother during production. And on the metallics, normally the other trick is to slow it down a little bit. That's the two primary things you want to do with metallic. If you go, for example, to an acrylic thread, looks more like a yarn, it's a 12 weight thread. Actually, for it to so well create the loop for the rotary hook, you got to run it with really tight tensions on the machine, and you will adjust your bobbin case accordingly for that type of thread, where you'll normally have to tighten it a little bit as well to balance out the tension on the machine. But that is the reason that the tension knobs exist on your equipment, is for specialty threads. The other 98% of what you're doing all the time, your tension knobs should look the same from the first to the last. Your other factors, when the thread feels extremely different, whether you're using a tension gauge, or just pulling the thread from the bottom and you know it by feel, what you're going to do is check your thread paths. A lot of times you'd be surprised how many times, even when we service machines, oh, this needle doesn't sew, this one doesn't work right. and it's simply threaded wrong. And sometimes it's hard to see. So don't stare at it for 20 minutes trying to figure out if something's wrong. Most of us are professional threaders. So normally from the tension knobs all the way down to the needle, you can rethread the whole thing in less than 1 minute. And you'd be surprised 9 times out of 10, the problem may go away. Your other factor there is your lint, dust, and fuzz. Don't let that stuff build up on the threads. Don't let it get pulled through into the tensioning system. Check your discs periodically. You can pull them apart. If you need to, annually unthread your machine. I know people hate to hear that because we all hate threading machines, okay? But take it apart, clean it. Q-tips, rubbing alcohol works great if residue and stuff won't blow out as far as the eyelets or the tension discs. So keep that in mind when you're running a tension test and things on your machine, that pretty much any machine I go to, whether it's 2 weeks old or 2 decades old, I can almost always match those tension knobs and get a consistent tension from the first needle to the last needle, okay? And consistency pays off. You got a great brand of thread, stick with it, okay? So when you run the tension test, and you can download this test. You can go to Ganold's website under their downloads. You can download the H-test on the machine. For example, in the pictures that you're seeing in front of you, the first and most important thing is, do we have nice, tight, clean stitches? That's what we want to see first and foremost. We do not sell the back of embroidery, we sell the front of embroidery. Now, any book or manual is going to tell you, if you're looking at the other picture as far as the back of this, looking at the pull of the bobbin thread, as far as the tension goes, textbook ideal tension they refer to as 1/3 or it's a 33% pull. The only way you're going to see a true tension test is your columns need to be close to 1 inch tall. They need to be close to 1/4 inch or 8 millimeters wide. On small text, you cannot tell tension because you will see specks of white for the bobbin, and that is normal. You cannot use a fill pattern because it will be white all the way across from one side to the other because it is simply a series of small stitches. You got to see that wide zigzag satin stitch, column stitch, to be able to see how the tension is on your machine. Now, the rule that I go by is when it's in range. This is a 20% bobbin pull to an 80% bobbin pull. I do not need every one of those to look identical to each other on the back. I can make it happen every day running this test a couple of times on my machine, but the truth is, one piece of lint, fuzz, dust changes everything. So don't try to be too precise. Don't do every single day tension tests. This may be something you want to run once a month or so on your machine, see if anything needs readjusted or cleaned. But, keep the tensions consistent. Keep them the same on your machine, okay? Always do your daily maintenance. That's probably one of the most important things. And we're going to cover that later on during this webinar. Okay, so talking about the tensions on your commercial machine, one of the things you're going to want to make sure of that we're talking about in the webinar is keeping your tensions consistent and the same. Again, the main reason there's tension knobs on a machine is for specialty threads like your 12-weight acrylics, which is a very thick diameter thread. Also, like your metallic threads where you'll normally need to loosen the tensions, tighten on your acrylics, loosen on the metallics. But for the most part, with your standard 40-weight thread, even going from a 60 to a 40 weight, even going from a rayon to a polyester, as long as you're staying consistent in that range of threads, you can actually keep all of your tension knobs the same. Keep in mind, it's very important that you're checking your thread pass, that everything is in the right hook, nothing's wrapped where it's not supposed to be wrapped. Normally there's instructions either in your manuals or sometimes labels right on the machine that's going to show you exactly how it's supposed to be threaded. From there, we're coming down. Again, consistency here. I just picked a few needles, 4 on this machine, to do a quick little test for this video. So the first thing you want to see is when you sew a tension, H test, I test, you can really use any letter. It has to do with the height and width of the columns. First, do we have nice, tight, clean stitches? That's what's important because we sell the front, not the back. Okay, from there, we're going to flip it over and see if we got consistency in the pull with the bobbin thread. So again, I've sewed, just 4 of the colors out of 15 here. We got pretty good consistency. Textbook is that 1/3 pull, pretty close here. a little less here, but the range is that 20 to 80% range. If you're there and you've got clean stitches, you're done, sew and make money. There's too many factors to try to micromanage your tensions every single day. Now keep in mind, this bobbin case on average costs maybe $10. This bobbin case is what causes majority of your sewing issues, and it is the constant between all the needles on your machine. So just an example, I've already sewed one of the colors here in that purple, number 14. So what I'm going to do is first make sure it's clean. You can take a business card. I can lift up no more than my fingernail. Never stick anything metal, but you make sure it's clean under that spring. Spring should be raised in the back, lowered on the front. The front is the only place tension is actually created. I'm going to take that tension screw, and again, I'm using my screwdriver from my Ganold kit because it works great for your needles and your bobbin case. And I'm going to loosen that screw 1/2 of a turn, not even a whole turn. And I can physically feel that that thread is looser. So I'm going to put that in. I'm going to hit start and let it sew part of this next letter. And you can actually see, being that loose, I already see some white thread coming up to the top of the embroidery. So I'm going to hit stop on that. I'm going to do a trim. Okay. I'm going to pull that off. Again, this is the one that just sewed. This is the one I'm sewing now. Needle 14, needle 14. Absolutely nothing changed on my tension knobs, nothing changed on my thread path. It was just a loose bobbin. This would be an example of what you would get if there's lint, dust, and fuzz built underneath the bobbin case spring, and it does not get cleaned. Okay, this is important that you clean it. A lot of people just want to tighten with the screwdriver. They flatten the spring and completely destroy the bobbin case. And then you're just fighting tensions every day of your life, turning tension knobs, trying to get a decent sew out for your customers. Now, if I flip that over on the back, I can see that I'm pretty much all white. I can see I got white thread on top. Now keep in mind, this is something, if you needed to touch this up, that's what they make the fabric markers pins for. You would use this with a lighter shade of blue, touch it up, fill it in a little bit. You know, don't tell your customers you used a crayon on their expensive embroidery. That's basically all it boils down to. Now I'm going to put that back in. I'm going to take the bobbin case back out. Now keep in mind, the only thing I did was loosen that screw 1/2 of a turn. I'm going to loosen it back the 1/2 a turn. And that's going to be pretty close to where the tension should be. Again, I know it's clean. I've already checked it. Now watch what happens if I turn it a 1/2 a turn too far. Now we got the scenario of the bobbin is way too tight versus the top thread. And we're going to sew the other 1/2 of this letter H. So I'm going to stop the machine. Now, if you notice a couple of things here, my white thread isn't showing anymore. I do have nice, tight, clean stitches. However, if you look close versus that first letter that sewed with really good tensions, this column starts to become narrower than the column beside it, or the one I sewed previously. Keep in mind, the tighter those tensions are, especially that bobbin on the machine, the more it pulls. The more it pulls, the column becomes a little bit smaller. So if I flip it over and look on the back, here's the extreme opposites of each other. No bobbin showing at all. You can feel a little ridge forms. If this wasn't hoop tight or one piece of backing and lightweight material, this would have simply bird's nested. Tension is tug of war between the bobbin and whichever thread is sewing on top. Whoever is the tightest, strongest is going to win. Top wins, bobbin comes to the top. Bobbin wins, colored thread goes completely to the bottom till it has one place left to go in the hole, and it takes the shirt with it, and that's a bird's nest. So what I'm going to do is put this right back on. I'm going to take that bobbin case right back out. I'm going to take my old screwdriver, pull that thread out of that pigtail. I'm going to loosen this up literally 1/2 a turn. Half turn too loose, half a turn too tight. Now I'm right back where I belong. I can feel it. It feels pretty good to me. So I'm going to wrap the pigtail back. Now, there's a thing called a 3-finger rule. You only use the door to take the bobbin out, never to put it in, because you always got to hear the click. 3-finger rule, hold the thread straight over the front. Once it's in the pigtail, thumb and forefinger of your right hand, clamp over the front and back. How many fingers are left? 3. No matter how big or small your hand is, it leaves 3 inches of thread. This is the correct amount to start sewing again. Too short, top thread will not connect. Take up lever, yank thread straight out of the needle. You're going to rethread your machine. Too long, and you leave this thread down here like this, that's how the thread gets wrapped up behind your rotary hook to a point if it gets too much back there, it'll alter your hook timing and you have to call your technician so we can come fix it. Or you're pulling your hook off and fixing it yourself. So, in this scenario, I just put the tension back where it was before I even started, and we're going to let it finish sewing this entire letter H. Example of it, too loose. Example of it, too tight. We stopped it. We're going to look again. Do we have nice, tight, clean stitches? Yep. You'll notice it's not pulling as bad as it was right here. We're going to flip it over. You can see my white thread is starting to appear again, so I probably want to go just a hair more on the bobbin itself as far as making it loose. Keep in mind that the top has not changed at all. Nothing about it has changed. And when I say a little bit, I'm not even going to do 1/8 of a turn there. And you can normally feel the difference when you do that. Then you wrap the pigtail, then the 3-finger rule. Always, always hear the snap and start. I'm going to stop it halfway through that one. I'm going to do a trim. Pull my hoop off again. Clean stitches. And much better on my bobbin, almost exactly where I started at. So keep in mind what happened here was a 1/2 a rotation on the tension spring on a bobbin case in both directions. And that is the variable. That is why the constant between all of your needles is that $10 bobbin case, not your $15,000 commercial machine. There's hardly no reason you ever turn those tension knobs other than specialty threads, especially if you got multiple operators. One cleans a bobbin, one doesn't. One turns tension knobs, one doesn't. It's a never-ending seesaw of back and forth between day shift and night shift on your machine. Hopefully that is a clear understanding of tensions on your machine, relationship with your bobbin thread to your top thread. The bobbin case, and I refer to this as the key to success, okay? Maintaining and cleaning a bobbin case. So just like what we're talking about, when you're talking about your single head machine with 15 needles, whether you got a 6-head machine that's 12 needles. So think about the single head with 15 needles. You have 15 needles all the way across. The tension knob should match and look the same because you got a good quality, consistent type of thread on your machine. But all 15 of those needles use one bobbin, one bobbin case, one rotary hook. So think about this. The bobbin case is the constant between all needles. So when you're seeing things happen like the white thread appear on the top of the embroidery, again, We want to turn the knobs. It is almost never the solution. You see it starting to want a bird's nest on you. Again, we want to turn the knobs, either tighten or loosen. It's normally not the solution. Check the most consistent thing first, which is the bobbin case. This is what gets dirty. This is what needs cleaned. This is what needs to be readjusted if necessary to maintain the tensions from the first needle to the last needle on your machine. Okay, most sewing issues are actually caused by roughly an $8 to $10 bobbin case, not a $15,000 to $20,000 machine. So keep that in mind. Okay, this has to be maintained. Life expectancy of a good bobbin case, if you actually take care of it, is pretty much forever. Not cleaning, not maintaining properly, you can destroy the bobbin cases. Over tightening the tension spring on a bobbin case and not cleaning it properly, you're going to destroy the bobbin case. Other than that, if you do a lot of hats, you do get some deflection of the needle. Digitizing is extremely important. Hooping is extremely important. On Ganold's website, there's additional information and videos on, hats and hooping correctly and things that you can review as well. But you sometimes, when that needle deflects, what will happen is it can snap off the pigtails, okay? They're at the top front of your bobbin cases. And then lastly, probably the worst thing you can do other than not maintaining this bobbin case is drop it on the floor on a consistent basis. When you pull the thread through your bobbin case, make sure it feels smooth and consistent, not tight, loose, tight, loose, tight, loose. When you feel that, check your bobbin. Sometimes you'll get a bad bobbin out of a gross, so check a second bobbin. Once you know it's the case, open the drawer, grab another bobbin case, nice and smooth, put it in. You solved your problem. The one that doesn't feel right, okay, goes in the trash. You don't put it in a drawer and thinking, I might need this later. It is called trash. And if you used your last bobbin case, please order another one or two. You never want to be stuck on your equipment without a bobbin case. You drop it on the floor, you don't see it, you turn around, you step on it and smash it. If you do not have an extra bobbin case, you are out of the embroidery business until you order more. It'd be like driving around the country, no cell phone signal, and no spare tire in the car. You're asking for trouble. Okay? Now the hook timing on the machine. So understanding how the stitch is actually being created on your machine. In this illustration, what you're seeing is just a simple illustration of what a needle does and how a rotary hook spins. All stitches are created counterclockwise. That's the direction that the hook is spinning. Now, when your bobbin is in your machine, if you have it threaded correctly, just pull the thread. You should be seeing the thread of your bobbin turn counterclockwise. If it spins clockwise to the right, that means you're actually threading your bobbin backwards. Most of your magnetic bobs and stuff that are available are wound the correct way so that when you pull, it does turn to the left. So the rotary hook spins counterclockwise. The needle goes up and down. I'm going to explain a few components and we'll get into more details of those here shortly. But the parts of your machine, if you think about where the thread sits, that is called a thread base. Okay, this is where the thread sits. Above that is either called the thread rack or the thread tree. This is where the thread comes up and out of the cones. And then from there, the thread is either going to go through tubes or directly down to what's called the tension base. Okay, the tension base also normally has your sensors on there that tells you when the bobbins ran out or the thread breaks. The tension base, primarily on most machines, is made of plastic. It's got all the tension knobs on it. It's got all the sensors on it. This is mounted and sits on top of what's called the head. The head of the machine has the needle bars, the take-up levers, the presser foot, and the needle holders. So what's happening is the thread comes off. It comes off the cone into the thread tree. It comes down into the tension base, and the first thing on the head it encounters is called the take-up lever. Take-up lever's job is to pull the thread off the cone and feed it down to the needle. If you don't believe me, just unthread that take-up lever and try to sew. It will not stitch whatsoever. Next thing it's doing is the needle is starting to engage with the needle bar, and then the presser foot comes down. Presser foot's job is simple on all sewing machines ever made. Its job is to hold fabric to the needle plate so the needle can enter and the needle can exit and a stitch can be created. Now on top of that, your machine has timing wheels, and there's very specific numbers on these wheels that are extremely important on your equipment. And the three most common numbers that you will have, period, is referred to as the hook timing position, the lower dead position, and the upper dead position. Hook timing is where the rotary hook point meets the scarf. This is the indentation on the back of the needle, which we will show shortly, okay? And then from there, the needle will reach what's called lower dead. Lower dead on machines can either be 0 degrees or 180, depending on which type of equipment that you have, okay? At this point, the needle has reached the lowest stroke it can go. The thread is being pulled the tightest that it can be pulled. From there, it has only one direction left to go, and that is up. And when it goes up, the thread becomes slacked and loose. This creates a loop behind the needle where the scarf is. This is the indentation. Within 20 to 25 degrees, the sharp point of the rotary hook connects, grabs the thread and pulls it, like you're seeing in this file, completely around the outside surface of the hook. When it gets to the top, the thread is pushed in behind the bobbin thread, in front of the basket of the rotary hook, but behind the support bracket that holds it in place. This is creating one stitch, and a stitch is nothing more than those two strands of thread, the top and bottom, twisting together, okay? If you get to the end of a letter or column, it stops and trims, and then you see it starting to fray or unravel or come out. Don't turn the tension knobs, okay? Don't try to make changes to your machine. This is an issue with the design. That means there's no lock stitch there. A lock stitch is nothing more than thread sewing back over itself, okay? And very short stitches to lock the thread into place. Just like when you use a sewing machine, you get to the end of stitching, you back and forward over itself, and then you clip the thread. All right, on a sewing machine, you lock the presser foot down, holds the material down so it can stitch. Okay, the exact same process is happening here. So when you see that something is unraveling, always have fray check available. Ganold carries that as well. Okay, it is a non-residue. It will not stain your fabrics, but it'll lock those threads in from the backside forever, because if it starts to unravel, it will continue to unravel. But how you fix this in production is go back to the computer, open it up, and figure out why there is no lock stitches in the design. The machines don't do lock stitches, they're in the design itself. So this is the process of the rotary hook or the needle coming down, the top thread going all the way around the needle after coming up from the lower dead position, and then it goes all the way up to the upper dead position, which is the highest stroke it can go, and the process starts all over again. If you're running at 750 RPMs, this is happening 750 times in 1 minute. This is the basics of how a stitch is created on a rotary hook sewing machine, which, by the way, was invented in 1851. So if you think about it, it's over 170 years of how a stitch is created. Really has not changed at all. Now, the next parts of this webinar, we're going to cover additional information as far as some of the components that I have been talking about. Now, as far as what we were talking about there, if you look at these illustrations, we got a support bracket in front of the rotary hook. You have the sharp point of the rotary hook that you can see in that top picture. This is what's timed with the scarf. This is the indentation on the lower blade of the needle. The front of the needle has a groove straight up and down. There's one little presentation here where you can see at your hook timing position, which is different on all machines, okay, which we'll cover here in just a second, of where the scarf comes into the timing position with the sharp point of the rotary hook, and the thread gets pulled in between and completely around the outside surface. Now, as far as the needle, standard needle in the industry, if you're not sure what needle you should be using, it is a DB times K5. That is the style. The size is going to be a 7511. 75 and 11 are the exact same increment of size. One is simply a European designation. The other one is an Asian designation. nation. Okay? The size of 75 and 11 roughly is 0.8 millimeters on the lower blade of the needle. If you do need fine details, smaller text, columns to be crisper and cleaner, you can go down to a 65/9. You can go to 60 weight thread. It's not right or wrong, but most of the time you're going to have a 75/11. If you're having issues, extremely thick hats, a difficult time sewing puff, then you may want to go up to an 80/12. It is a larger diameter blade. You may want to go to a sharp point, so it can get through the thickness of that material a little bit easier. But keep in mind, larger needle punches larger holes. Smaller needle punches smaller holes. So think about the detail of what you're working on. And again, if you're not sure, it's a 75/11. Ballpoint is the needle that you want. Okay? Now, learning the correct timing position on your machine. Normally you can find videos on this. You can call and talk to your tech support, your distributor for your equipment. There's always a lot of resources out there. Basic timing, hook timing on machines is usually a number like 200 or 25. So as a technician, the example I could give you is hook timing if you have an SWF machine, hook timing if you have a Tajima machine, hook timing if you have a Brother machine, their number is 200 degrees. This is the hook timing position on the machine. If you have a Happy machine, if you have a Baradin machine, their hook timing position, depending on the age and the model of the machine, is usually between 23 to 25 degrees. And some of that is whether it is a bridge multi-head, a single head, and again, age of machine. But their most common number is also 25 degrees. It's not right or wrong, it's simply the direction the sticker is put on their degree wheel. So if you think about it, lower dead on a Tajima is 180, hook timing is 200. There's 20 degrees difference. On a Baradin, your lower dead is 0 degrees and the hook timing is 25. There's a 25 degree difference. So all hook timing from lower dead is going to normally be between 20 to 25 degrees. And the wheels are located somewhere on your machine that you can usually find either by looking or accessing a cover, so you can check and see what the hook timing is. You know, I tell people the things that's going to knock your machine out of time. Of course, hitting hoops, we're going to cover more detail on. And breaking needles is a good possibility, but probably the number one is bird's nesting. Okay, when you're not maintaining that bobbin, you forget to snap the bobbin in. That's the easiest bird's nest in the world. The thread just wraps around the center post. Lack of oil, maintenance on the machine can throw hook timing off. Anything that can cause that hook that's spinning at 800 RPMs to go from 800 to 0 in a sudden stop can cause it to spin on the hook shaft, and then you're out of timing. There's always usually good tutorial videos and stuff. Most of the time I tell people, if you watch a video, you understand it completely. There's almost no reason not to try to set your hook timing, especially if you're having to wait 2 or 3 weeks for a technician to get to your location to fix your machine. If you get it wrong, the worst thing that's going to happen, you're going to break a needle. It's already out of time anyway. Best case scenario, you might be actually back up in production in a couple of hours, you know, with some help from your distributors or technician or whatever on the phone. There is hooks and gauges available. Your supply places normally sells them. The most common is the round styles. And again, it depends on what you're timing. Most of your block gauges are for the actual needle bar height. This is something a technician would normally use if he's retiming an entire machine or something. The round styles are the most common that even operators will own. Again, these can be purchased from your embroidery supply places. If you have one that's a half moon shape, this is usually designed to measure the depth of the needle, so like the 180 degrees. If you have ones that perfectly round, these are usually designed to do the timing at the hook timing position of, for example, 200 degrees or 25 degrees. Okay, and again, these are normally available for purchase if it's something that you need. Now, the rotary hook itself, and this is a common issue that we fix on probably 9 out of 10 service calls that we do. Keep in mind that a needle is the only thing metal that goes down inside of the rotary hook. So it's the only thing that's really going to scar or cut, or what we refer to as burrs on the rotary hook. Now remember, we was talking about how the stitch is created. So the thread is wrapping completely around the outside surface of the rotary hook. So burrs can cause a few things. It can cause thread to fray. Even though thread fraying, the most common issue there is the needle. Because what wears out on a needle is not the tip of the needle, it is the eye of the needle. What happens is the thread eventually wins, cuts a groove in the top of the eye of the needle, and the thread does not just break, it frays and unravels. The needles that will wear out the fastest on your machine, black and white, because that's your common colors. On average, you might be changing those colors at least once a week on the needles. You may have a neon green color on needle 8 on your machine, and it stays there for 10 years. And if you sew one small job with that needle is going to be good until your grandchildren pass away. It's all wear and tear, how much it's actually being used. But again, back to the burrs on the rotary hook, these can actually normally be removed. And this is without taking the hook off, without understanding timing, redoing timing. For best practice, normally I'd suggest you turn your machine off. Find your degree wheel, remove your needle plate, open your rotary hook cover where you put your bobbin case, take your bobbin case out, rotate it around, okay? And if you feel the nicks and burrs, sometimes you can see them. Take sandpaper. What me and my technicians use is 80 grit and 1000. If it feels really rough, start with the 80 grit, finish up with the 1000, make it nice and smooth, make sure it gets blowed out so you leave no residue, oil the hook well, put all your covers back on, return back to your home position on your degree wheel, and do a test sew out. It's actually pretty easy to remove burrs off of rotary hooks. So if you've been breaking any needles, anytime here recently or in the past, then you've got some sewing issues. So where the thread wraps completely around the outside surface, it can catch these nicks, the burrs. If it does, you can see the thread want to become frayed, choppy a little bit. It can cause the thread to push away from the rotary hook, so you may not have nice, tight, clean stitches. It may miss a stitch or two, so you might have some looping in the design. These are some of the things that can actually be caused by burrs on the rotary hook, okay? If you're breaking a lot of needles, make sure you stop and figure out why. We will occasionally break needles, but it is not a common thing to constantly break needles on your machine. So the more needles you break, think about it, the more damage you're going to cause to your machine. Okay, so what we're going to do, guys, is just give a brief overview of the hook timing on the machine. Also how to check and see if you've got any burrs on there that may need to be sanded out. So what I've done so far is I've turned the machine off. I've opened up my hook cover, removed the needle plate. Pretty standard as far as doing cleaning and maintenance on a regular basis. Now, better safe than sorry, I did turn the machine off. A lot of technicians may do this with it on, but just good practice, turn the machine off. Everything rotates and moves by hand. On this particular machine, the degree wheel is on the back. The hook timing on this machine is between 23 and 24 degrees. But like I said, depending on the manufacturer, the brand of your machine, your hook timing is normally going to be 25 or 200, again, depending on that brand. Now keep in mind, you can go to Ganold's website, you can go to their video library section. There is actually an entire, I think, 12-minute video of hook timing from start to finish. So you can see actually every screw removed, put back in, the timing ring being redone, the support bracket being put back in the proper position to be able to create stitches and all that good stuff. So what I've done is I've turned it off. I've engaged needle number 8. Normally when you set hook timing, we do recommend that you set it on the center needle of the machine because there can be some variance between the first and the last needle in your system. Now on this machine, the degree wheel is in the back. Again, if I just start turning and rotating, you will see how that sharp point comes around. And when it is at the 12 o'clock position, this is the hook timing. So just get me a little better view right there, just a hair more. And the sharp point. Hook timing is the relationship of the sharp point of that rotary hook that is now at 12 o'clock to the scarf, that is the indentation, the cutout in the back. It should be as close as possible without touching, so you check your deflection by pushing on it. On this machine, a good gap on that is probably closer to like 0.3, 0.4 millimeters, basically half the width of a needle. So this is what you're doing when you're checking your hook timing. If it's completely out of position, you're not sewing, then you're going to watch the full-length video, loosen the screws that are located behind here, the larger screws, and so on like that. Now to check the burrs on the hook, I'm going to rotate that back around to where you see the sharp point here at 6 o'clock, and then rotate it to where it's at 12 o'clock. And then you'll see this rolled round edge here at the 6 o'clock position. From that edge to that sharp point is where you'll find the burrs. And what I do is I'll rotate it around. I will feel with my fingernail, not my finger, and think of it as 3 edges. I'm feeling the inside, the outside, and the bottom. And if I find any nicks or burrs, actually this feel like there may be a little one right in there. Sometimes you can see them. At that point, what you're going to do, if you're me, you're going to sit down to do it. This is the sandpaper that we use as technicians. This is my 80 grit sandpaper if I feel a really bad gash or cut in it. This is my 1000 grit, so I'm going to polish and finish with this. If I find burrs that are just real light, I'm just going to rotate wherever position I need to, so I can sit there, fold my sandpaper, and get it at whatever angle I need. So again, we're doing this without it messing with the timing or anything on the machine. We're going to sand it out. We're going to feel, make sure it's smooth. Guys and gals, don't think you're smarter than the engineers. Do not use a Dremel tool on this because you will change the shape and it will no longer work, ever. But sandpaper is okay. Very important. When you're done with any sanding of the rotary hook, make sure it gets blowed out completely. We leave no residue inside that machine, and then make sure you oil the rotary hook on that racing. So blow it out and oil after you do any of the sanding. All right, part 2 of this webinar, we are going to discuss the reciprocator and needle bar drivers. Okay, these represent the exact same thing. These are the parts of the machine that drive the needle up and down so a stitch can be created. Now keep in mind, if you have a single head machine, you may have 15 needle bars, but you only have one rotary hook. You only have one bobbin case, okay? You only have one sewing arm. So behind the head, the needle case, in the center of that sewing arm is going to be the needle bar driver or the reciprocator. Almost all machines, this is a molded plastic, usually injection molded. These parts do not actually wear out on your machine. I've seen machines over 20 some years old and they're still in perfect condition, okay? But they're made out of plastic for a reason, and the reason being is they're a mechanical clutch. If you make mistakes, you get new operators, you get in a hurry, you're not using the trace features on your designs, you forget to check the size of your design, and you start hitting hoops. Your commercial machines can sew through 1/4 inch thick leather. They cannot sew through plastic and metal, which your hoops are made out of. So what happens is these drivers can get damaged, or what they're designed to do if they hit hard enough is break completely off. You'll know when this happens because the head is on, you've hit a hoop, but the needle bar no longer goes up and down no matter what you do. And normally you'll find that plastic piece has fallen out or laying behind the head case, okay? That's one of the worst things we can do is hit hoops in the industry because it's going to put your machine out of commission. So the ones you're looking at here on the screen, this is the one that's an entire assembly. These cost more than just replacing the plastic pieces. Sometimes because of aluminum screws and Loctite, the technician may have no choice but to replace the entire assembly. And you're talking about a piece that costs a couple $100. Most of the time, 8 times out of 10, we only have to replace the plastic piece. So you're only talking about a part that could cost $13 to $40. But think of them as mechanical clutches, because if your machine continued to try to sew through the plastic or metal, it could overload the machine. This could overload circuit boards and motors, and we would much rather have to replace a $40 to $200 mechanical piece versus electronics and motors that could cost thousands of dollars in repairs. So the ones that are designed with the triangles, for example, that you see here, there is a block on the back of the needle bar, the lower dead collar. That's what it engages inside of and drives the needle bar up and down to sew. The one you see on the right, this is called a needle bar driver. It creates the same effect, except the top of the needle bar has the notch in it, and then it drives itself inside of it to drive the needle up and down as well. When you're looking at your hoops, most of the time as a technician, we walk in the shop, the first hoop and the only hoop we normally want to see is the one you use most frequently, and that is your 15-centimeter round hoops. And of course, nowadays, everybody has the magnetic hoops and things like that, godsend to embroidery. But the most common hoop ever used in our industry is the 15-centimeter round. It is the one used for left chest embroidery probably 95% of the time. And what we're always looking for, and if you look at this example pretty well here, we are looking for the little nicks and chips that are missing on the inside of those rings. Even though people like to say, well, no, I haven't hit any hoops. Well, when you're sewing designs that really do not fit inside the hoop and they get close and you hear that little noise every once in a while, you're getting too close to the edges. The design's too big for the hoop and it's nicking the sides. This does cause damage to your equipment. It can bend your presser feet, it can break your needles, but it is causing damage to the needle bar drivers, the reciprocators on your machine. And again, if you hit hard enough, it's designed to snap off completely. So this is something you may want to check, with your operators and things like that. A lot of times you can go to the first or last needle on your machine. You can use a flashlight, and you can see this needle bar driver in there, and you can normally check its condition without having to remove literally anything off of the machine to see if there's any damage or issue and something that is going on. So remember, trace. It is the most important feature there is on your machine. Every machine has the same steps to production. Load the design, make sure the angle is correct, program the colors it's going to sew, but most importantly, trace, okay? Do not deal with wordage like, I think it'll fit. I might get away with it. Hey, honey, come here and tell me what you think. Those are all a big fat no. It does not fit in the hoop. Keep yourself at least a 1/2 inch safety margin all the way around the outside. It is either yes, it fits when you trace, or no, it does not. There is no in between. If it's yes, hit start, make money. If it is a no, you have 3 options. Option number 1, bigger hoop. Option number 2, smaller design. Option number 3, don't do it because you're going to tear your machine up. That's what you're going to do over time, okay? Now here's an example of some of the damage that we have found on reciprocators and needle bar drivers. So the one on the far left here, you can see that the little triangle is not a perfect squared edge anymore. This damage is normally caused because you are glancing. You are nicking the sides of the hoop. And you'll finally get to a point where a needle may not drive all the way down. It may bounce on you. This is common. The one in the middle, you can see that the top bracket has gotten bent. This has happened because on the inching stitch, it was so far off center on the tracing feature on the machine that the first stitch just went slow and completely through the plastic of the hoop. And then it's done this a couple of times and it bends the top bracket. So keep in mind that needle bar driver is now moving with 4 to 5 millimeters of play up and down. Therefore, it's throwing the timing off on the needle bars. Will it stitch? Yeah. Do you have nice quality of stitching? No. You're getting looping in the design. You're now turning your tension knobs. You're adjusting your bobbin. You're doing everything in the world to try to make it sew better. The solution, replace the reciprocator. The one on the right that you see, it hits so hard, you can see that the triangle is missing. If it hits hard enough, this is what it's designed to do. Now keep in mind on your larger machines, when you get to your 4-head and 6-head machines, they will have the same reciprocators and needle bar drivers, but they also have something else. Normally on their lower shafts on the table behind the machine and what's called the main gearbox, they will either have a fiber or a nylon gear inside of there. And what that is on those bigger machines is a secondary clutch. Because think about it, these reciprocators, needle bar drivers, are designed to break, okay? Think about it, there is strength in numbers. If I break one stick, it's easy, but if I have 6 sticks, I may not be able to break it, because if 6 hit hard enough at the same time, their combined strength may not snap off. So at this point, it's literally designed to rip that gear out of the back of your machine. The good news is it's a very inexpensive part. The bad news is it normally takes a technician a half a day to change one of those $40 gears. But again, we're saving the electronics on your equipment. This is the reason these parts are made this way on your machine. So just an example of what you would be looking at. There's without the covers on, and you're seeing the needle bar case inside under the cover, you know, needles 1 through 15, okay? There's a needle, a reciprocator, okay, with a dampening pad underneath. That's for the presser feet. So this is what it would look like if you pulled the head off the machine. Now this is something, unless you're extremely comfortable doing, I do not recommend. If you are, make sure you watch videos, tutorials, get help support from your distributors, your technicians, you know, or try to get them there as quick as possible to change. Now, one other thing I do want to point out while we're talking about this, if you look at that needle bar case, and all the way on the left-hand side, you will notice needle number 1, and then we'll notice needle number 4. What you can see is that upper dead collar is setting higher. Those collars are setting higher than those other needles, okay? The reason this happened on the machine, and this does take, you know, years for this to happen, but the reason that happened is the upper dead cushions, the collars themselves, were hitting the upper dead cushion, and over time it completely destroyed them. Those cushions are gone. This does require new cushions to be replaced, the needle bar to be completely disassembled. They just can't be snapped in. The shaft has to go through them. The reason this happened on the machine on needle 1 and number 4 only is because the customer left white and black in the exact same position for way too long. Think about it. Common colors are being used thousands of times more frequently on a daily, weekly, monthly, yearly basis than all the other colors on your equipment. Okay, therefore, that system is going to wear out faster than the other ones beside it that are identical. Solution's easy. Once a year, rotate the threads on your machine. People don't like hearing that because once you're an operator and owner, you go to your machine. You can go to your machine right now and you can program white, black, red, blue, and not look where those threads are setting because it's a habit. You know exactly where they are. So over too long a period of time, a couple of years, that's actually a very bad habit. Okay, move those threads at least on an annual basis. And when you do, put a sticky note on the control panel that says, hey, silly, you moved the threads. That way you don't come in on a Monday morning, your memory remembers where they was and you programmed the wrong colors. It'll take yourself about a week to retrain yourself where those common colors are. So, but keep that in mind when you're having issues with that white and black. How long's it been in that position? You're changing the needle, you're not getting a better result. At the end of the day, you've done all your troubleshooting, you finally move that white to another needle, it's running fine, and you're like, well, I'll worry about that other needle later. We've gone to people with 15 needle machines that they've been down to 6 needles running because they were worrying about those other needles working later, okay? So keep in mind, consistency. Same reason we rotate tires on a car. Don't rotate tires. What'll happen on 50,000 mile tires? You're buying new tires on the drive tires in about 25,000 miles. They will last half the time. So as we were talking about in the webinar, if you want to try to inspect your reciprocator needle bar driver on your machine, normally if you go to the last needle on this machine, it's needle number 15. We're just looking literally between the sewing arm, which is here. This is the needle bar or the head case that has all the needles in it. And I'll shine a little flashlight in there so you can actually see it better. This black piece that you see on this machine, like you saw in the webinar, is the reciprocator. Just a quick inspection, I can see it's nice, it's intact, there's no chips or dings missing out of it, it's got a nice crisp edge. If I push it over, it'll spring right back because it's a spring return. It's always a solenoid or a motor that will release this, but when it's engaging in sewing, what it's doing is engaging that needle bar, and that's how it drives that needle up and down when it locks all the way around it. When it's done sewing, ready to trim, and before starting, the motor or solenoid releases it so the needle bar will go and stay in the up position. So just a quick way, and be careful, make sure you're not hitting the spring. If I go in between, I can actually lift up and down, make sure I don't have any play on the bracket. If I push hard enough on a single head, I'll actually be moving the shaft of the machine. I'm not trying to go that hard. I'm just checking its condition. If you've hit hoops or things like that in the past, machine's not sewing as well as it should be, then this is something that you probably want to check just to see if you have any damage, like the pictures and stuff you saw in the webinar presentation. All right, part 3 of this webinar. We are going to talk about the trimmers, the pickers, and the wipers or upper thread hooks on your machine. The trimmers are the cutting system. The pickers are normally located in front of the bobbin case, and the wipers, the upper thread hook, is designed to grab the thread after a trim takes place. The most important thing to know about these components on your machine, they have absolutely nothing to do with how the machine sews and creates a stitch. These components are for the starting and stopping features on the machine. So first with the trimmers. The trimmers is basically a 2-knife system on almost every machine out there. One knife is fixed and one is movable. One is designed to open and grab the thread, pull it under the fixed knife that normally has the sharp edge on it, and create a cut. Truthfully, just think of it as opening a pair of scissors and cutting. You almost never are able to see the trimmers on your machine because they're going to be underneath the needle plate, or the one on the left, for example, they will be attached to the bottom of the needle plate. Life expectancy of your trimmers is pretty much forever. They do not wear out. Bird's nesting, breaking needles, things like that can cause damage to the knives, and maybe they have to be replaced or sometimes just adjusted because of bird's nesting. A lot of machines, single heads, you can simply open the knife like you see in that center picture. You can loop thread around that movable part and slide it underneath the fixed part, just to check and see how well your knives are cutting, or to visually check them and see if there's any nicks or damage on the sharp edges themselves. A trick there is sometimes taking a really good picture with your smartphone, because you can zoom in and see a lot better than like I can with my glasses nowadays. Okay? A lot of machines have test functions that can open a knife and you can do the trimming process that way. Some machines, these are mechanical as far as controlled by the shaft and a solenoid and plunger system and a cam, versus a lot of machines nowadays, they're electronic. So normally you cannot open them by hand while the power is on, therefore simply turn it off, and then normally you can open the knives. On a multi-head, it's quite a bit different. All of the knives are linked to each other, so they can be a lot harder to open and check without knowing how to properly disengage the one knife from the entire system. So make sure that's something that you review, talk with your distributor, or who you got the machine from, or technician. But again, it's just the trimming process. It what cuts the thread so it can start sewing again or move to another color. Pickers, again, have absolutely nothing to do with sewing. It is part of the start and stopping feature. They are primarily responsible for what we refer to as the thread or trim length after the cut takes place. So keep in mind, how a machine starts is 100% dependent on how it stops. And what I'm referring to is when the cut takes place. Okay, the wiper comes down and grabs the thread. How much thread is left? This is referred to as a trim length or a trim tail. If this is too short, when it goes to start sewing again, you'll notice your machine does what's called inching or slow stitching. This is giving the machine time for the top thread to connect to the bottom thread before the machine takes off at your program speed of maybe 800 RPMs. If the tail length is too short, what's going to happen is it's not going to connect with the bobbin within the first 1 to 3 rotations. Then the take-up lever going back up is simply going to yank the thread out of the needle. When this happens, your machine will simply say thread break. It is not a thread break. We refer to those as pullouts. A thread break is it's in the middle of stitching and the thread actually breaks or frays. Okay? So there is a difference between the two. And most of the time when you have this happen, check the picker. Your tails are being cut too short. They go in center of the pigtail on almost all machines, top to bottom, left to right. A lot of times, depending on your cover system, they can get bent easily by bulky items like sweatshirts, things like that. If they're bent, bend them back, but gently, okay? If you snap them off, you're not fixing it. Order a new one. They're maybe $15 for most machines. To test them, push them in by hand. All you got to do. They should go in center around the pigtail. You want them to be pretty much parallel with the support bracket that is above the rotary hook. The support bracket is what holds the basket in place so the bobbin cannot spin or turn. Only the top thread goes around the outside of the rotary hook. The bobbin never moves. It just sits there and waits to get wrapped or twisted together with the top thread. Make sure it springs back out every single time. Now keep in mind, technology-wise, and some things people haven't seen because, we've had a few years of a pandemic and things. There hasn't been a lot of trade shows. But probably within the last 3 to 6 years, there has actually been a few changes on equipment. And the biggest change that you're going to see on some of the newer equipment coming out is smaller cylinder beds. So the beds aren't as big, so you can get inside the smaller areas like the sleeves of women's shirts, larger pockets on fishing apparel, things like that. But because of this, what they did is they changed the technology where a good majority of machines, they don't utilize the picker any longer. And what they did was they figured out a way for the rotary hook to stop at a lower position, have the trim take place where it'll pull the thread longer before it gets cut to create those tails. Not right or wrong, it's a different system. But again, keep in mind, how it starts is dependent on how it stops, okay? The upper thread hook, okay, the wiper, the thread catcher, okay, all mean the same thing. If you're novice, if you're new, if you've really not paid attention to how the trimming takes place on your machine, this gets mistaken for the trimmer a lot of times. I have had clients literally sharpen like the inside of the hook saying, oh, it cuts perfect now, but the thread flies out of the needle. It's always going to. These have nothing to do with the trimming. Its job is simple. Once the trim takes place, the wiper comes out, grabs the thread, and pulls it between 2 pieces of Velcro, and it's a Velcro bar that's located behind the presser feet on your machine, okay, attached to the lower part of the head or the head case. Its job is simply to hold the thread until it's ready to be used again. If you've got a clamping system or a thread holding system in the front, or the spring on the older machines, that is your thread holder. When you thread the machine, you tie on threads, you pull through. The wiper in the Velcro bar is the machine's holding system during the embroidery process, okay? So that's what the trimmers, the picker, and the wiper does. Has nothing to do with sewing, has to do with the starting and stopping features of the machine. Most of the time, a wiper can be pulled out by hand. If not, normally turn the machine off. Also, there's test features in a lot of machines that you can utilize. What we're going to cover right now, guys, is the wiper, the trimmers, and the picker that's on your machine. Again, we discussed in the webinar that a lot of the new technology and stuff, the cylinder beds have become much smaller. They've actually managed to do away with the pickers. These components have absolutely nothing to do with the sewing of your machine. The sewing is the presser foot the take-up levers, the needle holder, the rotary hook, the bobbin case, the tension knob system, the backlash springs here for the take-up levers. Same as all sewing machines pretty much ever made has these components on them. You just have 15 of them in a machine like this, commercial. So looking at the wiper, again, I have the machine turned off. Normally on your single heads, you can pull your wiper down manually. So if you look, we're sitting here on needle number 8. So if I pull it out, what I'm looking for is if there's any damage, if it's bent, a lot of times you can just bend it back. Some of the older machines don't have the return or stop sensors on them and letting them know they're back up. So if a machine misses a trim and you're getting the wiper error, it's not because there's an issue with the wiper. It's because it didn't actually cut, so the wiper cannot physically go back up. So don't just think because you get the wiper return error or the upper thread hook error on your machine that there's a problem with it. It's normally, is the thread attached or not? Because if the cut does not take place, which is underneath the needle plate, then the wiper cannot pull the thread up into the Velcro strip. And on this one, it's attached with 2 screws on the side. There's 2 brackets underneath with Velcro on the top and bottom. If over the years it gets oil soaked or the Velcro gets damaged, they are actually pretty easy to change. You can just remove the entire bracket, clean up the old Velcro, put the new one in. I can tell you as a technician, we change those pretty often, especially on the older machines and stuff because they wear out. The Velcro doesn't hold anymore, and because the thread is just falling out all the time, getting caught in the rest of the embroidery. When you do put that new Velcro in, it's almost always too thick. So we actually carry around our stitch erasers and literally shave the Velcro down thinner so the wiper can do its job freely, but there's still enough material there to hold that thread until it's ready to be used again. The spring in the front is simply your thread holder when you're tying on, pulling through, rethreading a needle. So if we come down here and we look at the trimmers, again, trimmers are always a 2-knife system on almost every single machine made. This one's called a flex knife. Whenever you see flex knives, those are pretty nice because if they ever do get damaged, they are pretty much R&R. We refer to that as remove and replace. There's almost no adjustment to them whatsoever because the knife flexes. This is the movable knife. It is controlled by a motor on this machine. So with the machine off, I am actually able to open the movable knife. So I can actually inspect the knife, no damage from the needles. I can see the cutting blade here on my fixed knife. And then if I want to test how well it's cutting, I just pull out a nice long piece of thread off the machine or another cone of thread, fold a loop, and I actually like doing 2 loops. So it's actually 2 pieces of thread, put it around the movable knife, hold it back tight. Oh, I missed my 1 loop there. Hold on a second. There we go. Put it over that movable knife, hold it back tight because this is the way the machine would actually be cutting the thread. It swings open, grabs the thread, and then it closes. And when it closes, what's going to happen is the cut is going to take place. And a good knife will look like it was cut with a pair of scissors. This machine's roughly 8 years old. It's been taken care of. So again, the life expectancy of knives, almost forever. Now, what controls the length of the tail, how much thread is left when the wiper comes out and grabs it, pulls it in the Velcro? This is the picker system. Again, some of the new technology don't have the pickers, so don't be alarmed if your machine doesn't have one. They just change the rotation angle of where the hook is when it actually stops and cuts the thread. So instead of being at the top position, the thread is actually closer down to the bottom, giving it a longer tail during the trim process. Pickers can be easy to trim. This one's a little different and nice. We do have a nice cover that goes completely over the top of it. Some covers are open or you can see exposed pickers. They can snag and catch, and you can see, it can be a pretty flexible metal. To check a picker is simple. Make sure you push it in, and it should immediately spring out when you let go of it. Push it in, spring out. And then you're checking to make sure that the picker is parallel with this support bar. So when I push it in and I'm looking right underneath there, those 2 objects are parallel. If I got angles to it, then the picker is bent. So bend it back in the proper position. It does go in center of the pegtail, top to bottom. left to right. You got height adjustment as far as adjusting screws normally on the side. If you need to adjust left to right, it's usually by the base. The picker base is this bracket here that comes out and holds it into place. Those screws are located directly right here underneath the bed. But again, this is the trimming parts, the picker, the thread catcher, the holder part of the machine. It has nothing to do with the sewing. It's the starting and stopping on the machine. In part 4 of this webinar, we're going to discuss the presser foot, the take-up lever, check and take-up springs on your equipment. Okay, presser foot, simple. Presser foot's job on all sewing machines ever made is to hold the fabric to the needle plate so a needle can enter and a needle can exit and a stitch can be created. Most of the time, you do not want the presser foot to exceed higher than 1 millimeter in height. On your older equipment and stuff, if you turn to the lower dead position, which is normally 180 or 0, depending on which brand of machine you have, it's the lowest stroke the needle goes and it's hitting the needle plate. This is normally simply because of wear and tear. This has a lot to do with the felt pads, the spacing cushions that's inside the needle bar case, or a dampening system or a cloth hold refers to the exact same thing, presser foot or cloth hold. Okay, and its job is simply to hold the fabric to the needle plate so a needle can exit and enter and exit and a stitch can be created. If it's too high, it creates flagging of the material. If it's too low, it's still going to sew perfectly fine, but normally what you will have is what we would call shadowing. It's compressing the fabric between the presser foot and the needle plate. So if you do have the shadowing that takes place on the garments, again, it's compressed fabric. It can usually be brushed away, or what you're going to use is, for example, a spray starch. That's usually the best thing to get rid of the compression or even the hoop burns or rings that you get in your fabric. Okay, the purpose of a take-up lever is to feed the thread from the spool down to the needle. Your take-up lever should always be in a straight line from the first needle to the last when your machine is not running. And again, make sure that they're always threaded. Sometimes you'll miss this if you have a thread break and then you can't figure out why that needle will not sew. It will not sew because the thread's not being guided down to the needle. That is the main purpose of the take-up lever. Again, all sewing machines have this component. The purpose of a check or take-up spring is when the take-up lever and the presser foot go down and the needle goes down and a stitch is created, this system has to cycle all the way back up. Therefore, the take-up lever has to go up, the presser foot has to go up, the needle bar has to go up. So as everything goes back up, the thread becomes loose or slacked. So the check spring's job is to simply pull the excess slack up so the system can go back to the top and start the whole thing all over again 800 times in a minute, if that's the speed at which you're running at. Part 5 of this webinar, the brains of the operation. That is your X and Y drivers on the machine. This is also referred to as what's called the pantograph. Pretty simple explanation. All files, the most common stitch file used in the embroidery world is .dst. It's compatible with almost every machine, every software out there. It's normally what you're going to get from your digitizers. Okay, the pantograph is what creates your design. This is what moves the hoop in the X and Y axis. All of your stitch files is nothing but 9th grade geometry. It is plotted points on an XY graph. If you have, for example, 8,000 stitches in a logo, it has 8,000 negative and positive points on an XY graph, all starting from the center, 0, and returning to the center, 0. And those commands are actually in that stitch file, and that's how your machine knows how to start in the center and go back to the center, okay? If you're having issues with movement, for example, on your pantograph, a lot of times you want to check the belts, okay? These are almost always belt or pulley driven by a motor. The easiest way to do this is simply turn your machine off. Your pantograph can move by hand. You can grab your tubular arms that stick out. You can move them left to right. You can move the entire pantograph forward and backwards. That is your Y-axis front to back. Left to right is your X-axis, okay? You can access covers. You can shine a flashlight in the slots of the movement. Check those belts. We do, on average, change belts on machines normally between years as young as 12 years old and as old as 23-year-old. Sometimes it has a lot to do with location, geography around the country. If you're in southern Florida, your machines have been in a warehouse environment their entire lives. In the summer, humidity, heat index, you're running 125, 30 degrees in there, your machine may need belts within a 10-year period. It is best to run your equipment in a conditioned space, okay? So not right or wrong. Sometimes simply age. If your machine is running good, but you start losing registration, it's slipping, check those belts. You'll be surprised once they start to disintegrate, and you're always sewing your left chest most of the time in a 15-centimeter hoop. Only that area of the belt's going to be gone because that's the area that's been used millions of times, thousands of times, left to right as it stitches, and that part of the belt is literally physically missing. Mounting your attachments and stuff, for example, your cap driver. Your machine isn't smart enough to know it has the cap driver on it. If you got a smaller brother or baby lock, it's because there's a sensor there that knows when you take the A-frame off and you put the cap driver on. You can go into your settings and tell it cap mode on your commercial machines. You can set the limits of that on your machine. But when you put the cap attachments on your machine, it is a cylinder or drum that's either turned by a strap or a cable. It is still moving left to right, that's the X-axis. It's simply allowing the cable to rotate the drum to create the stitching. And of course, all hats sew upside down on all machines. When you're binding on a cap driver, but you take it off and it's sewing fine on flats, check what's binding, check what may not be mounted correctly, see what screws came loose. Again, the easiest way, mount it, turn the machine off, and push everything by hand so you can see what's rubbing, what's not connected, what may be worn out, what pieces may need to be replaced. Okay, but this is the XY driver, the pantograph. This is the brains of the operation. This is what moves to create a stitch. Keep in mind, your very expensive commercial embroidery machine is just a sewing machine. Stitches are only created in one spot over time forever. The hoop is what moves, and it moves by the pantograph. All right, we're going to talk about the brains of the operation. This is the control panel on the machine. This is a touch panel on this particular machine. You have the ability of selecting what hoop and sizes are on the machine. This is the tubular arms. This is referred to as the pantograph. The tubular arms is what your hoops are going to snap into. These are adjustable in and out for the various size hoops that you may want to use with the machine. Normally the arms come off, and then you got a cap driver system that you're putting in. Major difference is it's a cable or drum system. It simply rotates, but the pantograph itself is still making the exact same movements. It's just that device is a cylinder drive, so it just allows whatever item you put on it to rotate, for example, your hats. The positioning and everything, it's as simple as when you're hitting your buttons and controls on the machine for forwards and backwards, left and right. As we were discussing in the webinar, if you're getting registration issues, binding, check if anything is loose, not moving correctly. Easy way to do that on most machines is simply turn it off, especially if you're binding, for example, in the cap driver system. Turn it off, and as you notice, literally everything can be moved, checked by hand. If you feel any slippage or something like that because your registration is in the X movement, remove your top covers, expose that belt and pulley system, see what's loose, see what's fallen down inside of there. Sometimes you'd be surprised how simple the fix can actually be. The Y-axis movement is simply moving the entire device forwards and backwards. So the carriage and belt and pulley drives for that on this machine is located on each side. Again, covers can easily be removed with a few screws to check and see if anything had fallen down inside. If you got a belt because of the age of the machine, humidity because of warehouse environment, that the belts are basically worn out over time. So the simple things to check. So just keep in mind, sewing arm, sewing bed, pantograph. All of this is just the sewing machine. Stitches never move, they sew in one spot. This is what moves. This is the computer, the brains of the operation. controlled by the CPU input-output board to send the signal to all these components and make this movement to create the design. And remember, it's nothing but plotted points on a stitch file. You know, everything starts in center, goes back to center. Okay, so we're going to talk about some of the major sewing components on the machine that has everything to do with sewing. Just a quick recap of what we're looking at here completely on the machine. This is our thread tree. This is where the thread comes up and starts its journey down to the needle. Down below it, as we refer to as the thread base. So this is where the thread is setting. This particular machine is numbered from right to left. So 1's on the right, 15 is on the left. Coming down through the tubes, we come into our tensioning system. Some machines have 1 tension knob, some 2. Some of the older ones have 3 knobs on the system. You might see some up on your thread tree actually there as well. Normally you're going to see a disc or wheel sensor. The older machines, the backlash spring that you see around the large tension knob is actually the sensor. On this particular machine, they incorporated the large tension knob with the sensor. The disc here that spins is actually also the thread break detects the sensor, whether the bobbin breaks or the bobbin runs out or the top thread actually breaks. Now from there we come down from the tension base, and this is the head of the machine or the needle bar case. We have the take-up levers that are mounted here. A lot of machines have some type of guide or rail system that keeps them all in a straight line. So keep in mind, behind this entire system is the sewing arm. Down here is the sewing bed. This is the frame of the machine. This is the pantograph. This is our tubular arms. Front to back, Y-axis, left to right, X-axis. Now from the take-up levers down inside, you'll see we've got the 15 needle bars. They got return springs up here at the top that hold them in the home position. Okay, nice and free, exactly the way they're supposed to be. There's felt pads, usually in the lower and middle part of the section, so when you do oil those needle bars, you know, the felt pads hold the oil in place and those stay nice and lubricated forever. Here, what I'm going to do is come down. This is our check springs, okay? So when the take-up lever goes back up to pull more thread down, these springs is what takes the slack out of the thread. Without either one of these two things, you don't thread the take-up lever, it's not going to sew. If you miss the check springs, you're going to have poor quality embroidery. You're going to get a lot of looping and things like that in the stitches. So if you see that happening, check your backlash springs. Make sure that they're nice and free. They're coming down, they're retracting back up, and they're not bound or got pulled. Some people get in a bad habit, thread gets caught, they'll pull it, it was wrapped here, and then you damage a spring. A lot of times these can be a little difficult to change. If it's really bad or multiples, you can just replace the block instead, so they're all perfectly brand new. Inside of here is the little roller, so the thread comes down through the spring, back up, and then down, and feeds to the needle. Then we have our presser feet. So our presser feet, if I engage a needle right now, this is the active needle because the machine is on needle number 8. Remember, 1 sewing arm, 1 sewing bed, 1 rotary hook, 1 reciprocator, 1 complete driving system or sewing machine. From here, it would sew counterclockwise. So if you was watching the hook spin, this is the way it would sew. When it hits here, this is referred to as the lower dead. On this machine is 0 degrees. Some machines are 180. This is the height of the presser foot, approximately 1 millimeter off the plate. Some machines have jigs for this. If you don't have one, what does work well is actually a dime, okay? So we don't want it touching the plate, but we do want her pretty close because the presser foot's entire job in life is to hold that fabric to that plate so a stitch can be neatly and cleanly created before the take-up lever and the presser foot come back up to start that cycle all over again. If you ever do lock a needle down in place, if the machine is on, you can simply do a trim. Everything will return up and in the home position. Part 6 of this webinar, TLC, the tender loving care of your machine. We're going to discuss the oiling, greasing, and cleaning of your equipment. By far, this is the most important part of this webinar. Maintaining your equipment, having it look and sew just as well on Fridays as it does on Mondays, having it look and sew just as well in December as it did in January, having it look and sew as well 20 years from now as it did when it was brand new. Now keep in mind that the life expectancy of most quality machines out there is right around 15 years. This is about the time frame when the manufacturers stop making the electronic components. Mechanical, forever, pretty much never an issue. You can find repurposed parts, used parts, old machines for parts, things like that. But keep in mind that the life expectancy of a good machine is around 15 years. First thing we're going to talk about is the rotary hook. This is basically the only daily maintenance that has to be done on your commercial embroidery machine. The rotary hook is where the bobbin case snaps into. The racing of that hook, and you can see I'm pointing with the arrows here, needs to be oiled every 4 operating hours. Not once a day, not once a week, 4 operating hours. So if you're busy, you come in at 8 in the morning, this gets blowed out. The best thing to clean the area with is air. Canned air will work. However, a nice quality air compressor will work a lot better. Your pin oiler is the best that you can use as far as getting 1 drop of oil on the racing of that hook every 4 operating hours. If you ever take a bobbin case out of your machine, because you're changing a bobbin case very frequently, every hour, hour and a half if you're busy, because the bobbin thread is running out. If you ever take that bobbin case out and it is even slightly warm to the touch, okay, that rotary hook needs oiled, and it needs oiled ASAP, okay? If you're not sure, what you can do is take the bobbin case and you touch your cheek with it. Your cheek is a lot more sensitive than your fingers, and you can tell if that bobbin case is warm or not, okay? Only daily maintenance. When I do these live presentations and stuff, I tell people all the time, okay? 3 minutes of maintenance twice a day on your machine is way cheaper than this 300-pound technician showing up at your embroidery shop, okay? Keep it clean. Keep it oiled. Because remember, this is where the bobbin case lives. If it stays clean, it doesn't need to be adjusted. If it doesn't need to be adjusted, you won't be turning the tension knobs on the top of your machine that are not meant to be turned or adjusted unless you're using specialty threads. Consistency is the name of the game. Do it the same, do it frequently, do it consistently all the time. We all get busy. We're all like, I'll do it this afternoon. I got to finish this order. It's got to go on UPS. I get it. Go in 5 minutes earlier. Do the maintenance on your machine. Okay. The sewing arm and sewing bed of your machines. On average, these are normally oiled every 2 weeks. Whether you have a pumping system, okay, maybe once a week. All right. Some beds, for example, don't have the oil ports or holes inside of them. That means that they're not bushing inside of there. There's sealed bearings. Those are, so they do not get oiled. They do not get serviced. You don't do anything to those. Your machine will normally have labeling on it. It will normally tell you where the oil parts are. It'll tell you the frequency and things that you should be oiling. But on average, a sewing arm and sewing bed on a 40-hour shop is oiled every week. If you're doing every week and you're not getting oil coming out onto your garments and things like that, then you're on a good oiling schedule. If you're in a very busy shop, a plant facility, and you're running 3 shifts, this schedule needs to be bumped up to maybe every 5 to 6 days. It just depends. It's by use, okay? So the good news is if you're not sure, oil it. You're normally never going to damage your machine at all, but you may get oil onto your garments. Now, if this does happen, keep in mind there's always solutions. For example, Ganold sells a product. It is referred to as PSR. What it is a dry cleaning fluid, and it will take oil pretty much out of any fabric. So it's always a good canned product to have laying around the embroidery shop. Okay, the take-up levers and the needle bars. These normally want to be oiled, okay, about every 4 to 6 weeks, especially the needle bars. Make sure they are getting oil in there. Now in the illustration, you can see that we're using a larger spout oiler. Actually, the spray, I like the spray oil for this, like the Alba 5. That's available from Ganold as well. One spray is 1 drop of oil, but it has the long nozzle. It's easy to get in. Hit that needle bar. No covers or anything has to be taken off. If you soak these too much, you're getting too much oil. You're going to come in, on a Monday morning and you're going to see like oil coming onto the eye of the needle like it's getting ready to drop a tear. Okay, if that's the case, back off. You're putting too much oil inside the machine. You can take your duster, your can of air, your air compressor, pull your threads down long. You can blow off that excess oil and go straight right back into production without any issues. But again, back off on your oiling because at this point you're oiling too much. Greasing on majority of machines is every 6 to 12 months. This is something that me and my technicians do when we're doing our PMs or preventive maintenance for our customers. We're going in once a year. They're paying us to inspect their machines, check for the wear and tear, make any necessary adjustments, grease the machine, check and make sure their oiling is being done properly, nothing's dry, nothing's starting to rust, test the machine at this point, just to give it a clean bill of health. And again, this is something I would normally recommend if you're a busy shop, normally on average about once a year. We do have some customers, we service their machines every 6 months because they stay that busy and they just want them to be in the best shape they can be, all year long. Okay, so not right or wrong. But you can check your manuals, check with your distributors, what the schedule is, where your gears are, bearings, things like that if you need to grease. But again, it's usually not as frequently when you're getting there. Cleaning, I cannot stress it enough. Here's a picture of a Tajima. It's 19 years young. Again, past its life expectancy, mainly because electronics still in production, but you can see how clean the area is staying. It looks like it did when it was brand new, and it's 19 years old. Stay organized. Keep your equipment clean. Keep your tension knobs tensioned the same. Okay? Keep things organized. One of the worst things you can do is leave threads and cones piled up or loose threads on your machine. The back of your machine, the table, is not a storage area. It's not a work table for you to work with your pens and pieces of paper or your weeding tool from your cutting machine. Especially don't put your threads on there. We fix things that you think would not normally happen in your shop. Okay, for example, somebody pulled the head off their machine. They didn't get it flush back into place. They tried to tighten the screw and they cracked the head. Just the parts alone was $1,500. It wound up being about a $3,000 repair by the time I got a technician there. Okay. Again, if you're not comfortable working on checking any part of your machine, leave it to the professionals. Always, check with your distributors, your technicians, things like that. Here's an example of a thread just hanging loose off of a machine, and it got caught on the rotary hook, and what did it do? It unwound the entire spool until the machine physically seized. This right here was so bad, it took over an hour to cut that thread out. I've seen this same thing happen on the shafts on multi-head machines where it'll seize up because thread is left on the back and there's little slots where those gearboxes are and the shafts are running through there. If the thread touches that and starts wrapping, it undoes the entire spool. And then again, you're just looking at an expensive repair because of a $7 spool of thread that should have been in a box, on a wall, or in its storage container, not setting loosely on the back of your equipment, waiting to create a problem. Okay, so if you are in the scenario of when you get a bird's nest, it is not fun, but it is going to happen from time to time. I could hoop something loose, I could really alter my tensions, but the truth is the easiest bird's nest in the world, and I promise you, we've all done it at some point in time, is you've done your maintenance, you've done your cleaning, you did it in the afternoons, you did it in the morning, you come in, you go back to work, you're in the middle of a job, and guess what you do? You literally forget to put the bobbin case back in. Sometimes you catch it in time and sometimes you do not. So what we're going to do is open this up so you can simulate what's going to exactly happen when that tries to sew without a bobbin case. The thread is going to instantly wrap around the rotary hook. This is going to attach the fabric. It's going to pour the shirt down inside of your material. When this happens, this is Ganold's Bird's Nest Toolkit. We're taking our long hook. We are taking our long X-Acto knife that does come with an extra blade that you'll never need if you don't do this too often. Be careful, this is not a toy, okay? The hook is so you can come in underneath the material on the top of the rotary hook. So you can come around it, lift up a little bit, and then go in between the needle plate and the bobbin case with the X-Acto knife. You're going to cut that thread, lift up, make sure it's free. Yep. And then once you have that, now you're able to take your hoop off, clean out the area and the thread and the issue that you had. Yep. And of course, this time, make sure the bobbin case is in. And again, just for a video reference, that was the quickest way in the world to create a nice bird's nest on your machine. Again, make sure all the thread and everything gets cleaned out from inside of there. Always, always, always hear the click. So that part is solved. So now we got this issue here. We started the bird's nest. You flip it over, you'll see we got this problem. As long as we didn't damage the shirt, what you can do in a scenario like this, take your Peggy stitch eraser. Most people keep them close to the machine because it makes it a lot easier to fix your mistakes right there in the middle of production. I'm going to clean that off. I'm going to take my tweezers out of my toolkit. You cut from the back. You remove the stitches simply from the front. Okay. Trim off any excess. Back up to the point once you get the garment back on the machine. Now, if you did start to create a little hole or something of that nature, what you do is you take an additional piece of backing, and whether you use it all or just a piece, what you do is you want to float it in underneath and then continue doing your embroidery. So to keep your machine humming, products, for example, your oil pens, the toolkit, this has the tweezer snips, the perfect screwdriver actually for changing your needles, as well as adjusting your bobbin cases. I don't go anywhere without my small toolkit that I use from Ganold. The Bird's Nest kit comes in handy. This is a long, basically X-Acto knife with a hook system that comes with it. This is if you've got that really expensive item on there, a Nike, a North Face jacket, Cutter and Buck, something like that, and you have a bird's nest, you can go in underneath the needle plate and start cutting that thread away. And again, if we're lucky and we save that one piece of apparel, it done paid for that bird's nest kit 3 times over, okay? Your Alba, this is where you're going to get your oil, your hook wash, and your canned air. Small shops, you're okay with the canned air. Larger shops, high production volume, air compressor is going to work way better for you over time. The spray oil, the Alba 5, again, me and my technicians use that on a regular basis. Bobbin cases, do not ever get caught without extra bobbin cases for your equipment. Because if you drop one, lose one, damage one, and you don't have an extra, you are out of the embroidery business until you order a $10 part that should have been sitting in the drawer and there if you need it. Because it's better to have it and not need it than need it and got to wait over a 3-day holiday weekend before you can have your machine back into production. Now, with bobbin cases, there is actually an anti-backlash spring that comes on the inside of some bobbin cases. It's a blue or gray spring that's on the inside around the silver post. Now keep in mind, unless you're winding your own bobbins, metal bobbin cases, that spring is almost never needed. So keep that in mind. You can order your bobbin cases with or without that spring. So if you're using magnetic, that's their only rule. No backlash spring inside of there, okay? And cardboard, plastic bobbins, okay? Sideless bobbins, cardboard sided bobbins. None of those type of bobbins need that spring. So if you don't need it, just order the bobbin cases without the spring. You normally almost always have that option, and they are a little bit cheaper at that point. If you don't have consistency in sewing on one head to a 6 head right now, it gets better if you move your bobbin case from one to the other. If they don't look like they're in great shape, they look like they did during this webinar, they're dirty, the springs are flattened out, they've been bent, by all means, order 6 brand new bobbin cases. You may be surprised how much better your machine is going to run. Okay, and then start maintaining and cleaning that bobbin case. Okay, Ganold offers, the free education for you as far as the educational videos on their website under media. We hope to be doing a lot more webinar content and things here in the future, as well as, eventually returning back to those live trade shows out there that people love to see us at. Pro tips and everything to help save you time and money. All right. Ganold Digitizing, 100% guaranteed. They offer free estimates. There is a product code there. If you want to give it a try, it's 50% off your first order. Okay. Now, you've been seeing this throughout the entire thing, but questions and answers, if you have questions, please put them in the comment section. We're going to be more than happy to answer your questions. We will respond, as soon as possible. It depends on the speed at which they come in, how busy we get, and things like that. But we'll try to keep it within a timely manner. And then what we're going to do is provide basically a fact sheet or, a Q&A. So that way, as the questions come in, we're going to be providing the answers to basically everybody that attended the webinar. That way, just to share information. Knowledge is power. And there's a disclaimer here, due to the number and make and models of embroidery equipment and machines out there, we're not always going to be able to answer every question that you got. Our first suggestion is look at your manuals, call your dealer if you got specific machine questions. Feel free to email me as well. My email is right there. That is the absolute best way to ever contact me personally. And again, as soon as possible, I'll give you the best answer I can, or refer you in the right direction if I don't know that answer. I've only been doing embroidery now for 31 years, and I actually do know quite a few people that have been doing it longer and actually smarter than me. So if I don't have the answer, I'll do my very best to make sure I put you in contact with the right person to get that answer. Supply questions, application questions, anything simple or more basic that as far as products or anything, just reach out to your Ganold marketing team. Their email is right there. Okay, thanks everyone for attending. Hopefully there's something that you got from this webinar that will hopefully make your day a little bit easier, maybe solve an issue or something that you have. And remember, the more you know, the better you sew.